Okay, we're moving on to SAT Test 3 Section 8. So this one, number 1, 3/4 of a number. 1 second again, you'd think I keep my pen ready in time. 3/4 of a number, that would be of means times a number, so it's 3/4 of means times is 18. So we're going to solve this for n. So we get n equals we're going to multiply both sides by 4/3. So we're going to get 6 times 4, n is 24. Don't get too excited because that's not the answer. You need to take it times 1/4. I'm just making sure my screen thing's recording. So we're going to divide by 4 and we get 6. So let's get 6. Hold on a second. I want to make sure I'm recording this. Okay, looks like I am. All right. For all integers, here's our symbol problem. K star is defined by k times k minus 1. What's 5 star? So all we do is we replace the k's with the 5. So we're going to get 5 times 4, and that is 20. Now that was easy. All right, next ones, 3 through 5. All right, let it load. Here we go, another chart. This is an easy chart though. Let me just slide it down a little bit. The graph above shows the effect of aging on the diameter of an eye pupil. Based on the graph, what is the best estimate of the age in which the average diameter of the eye pupil during the day will be equal to the average diameter of the eye pupil at night? Well, the dotted line is night, the solid one is day. The point where they intersect is years of would be 45. Okay, next one. On each of the days, Monday through Friday, Tony spent 1 hour commuting to work and 1 hour commuting back home. What fraction of the total number of hours in these 5 days did she spend commuting? Well, there's 24 hours in a day. How much did she commute? She commuted 2 hours. That's 1/12. And it's going to be 1/12 of every day. So how many hours in these 5 days? It would be 1/12. Yeah, that seems a little bit too easy, but that's all it is. What fraction of the total, I mean, you could multiply the total days would be 5 days, right? And it would be 2 times the number of hours she commuted times 2 times the number of hours in the day. So you're multiplying by 5 over 5, so that's the same as 1. So it's 1/12. Okay, this one. This says, what is the value of x plus 1 squared? So basically, I'm just going to square both sides like this. Square both sides. If I did that, the square root, when you square a square root, you just have what's underneath the radical. It's going to equal x plus 1 squared. So what equals x plus 1 squared? 3 does when you square both sides. All right, 6 through 9. All right, let's scoot up a little bit. I can't see the top problem. All right, this is the typical, it's the bigger angle is opposite the biggest side. So this is going to be your biggest angle. Let's just put 3 loopy-doos on there. The next biggest one is going to be this one because 9 is the next bigger one, and the smallest one is 8, so that's going to be the smallest angle. So if we're going to put these in order, less than, the smallest one is going to be T. The next smallest one will be R, and the next smallest one will be X. So which one is that one? That is going to be A. So just remember the bigger side is opposite the biggest angle, and vice versa. The biggest angle is opposite the largest side. See, that's opposite. See, this is opposite, and this is opposite. Okay, next. A little trouble sliding. Okay, absolute value. There's a way to do these problems, but we're going to just pick the answers. So let's just start with 1. If you put a 1 in there, 6 minus 5 is going to be 1. Is 1 greater than 20? No. Now you could go down because you're thinking I got too small of an answer, but let's see what happens when we go down to D. So it's 3 minus 15, 6 minus 15 is not going to give us something greater than 20. So I'm going to go the other way. I'm going to put negative 1 in. 5 plus 5, so this one doesn't work. 5 plus 5 is 6 plus 5 is going to be 11, and that's not greater than 20. If I put, we need a bigger number. If I put 6 minus 5 times negative 3 is going to be 15 plus 6 is going to be greater than 20. You could try the 5 down here, but what's going to happen is you're going to get a smaller number. You're going to get 6 minus 5 times 5, and you're going to get 6, what did I do wrong there? 6 minus 25, the absolute value of that is not going to, it's going to be 19. So that one doesn't work. So that's the only one that works. All right, we're going through this fairly quickly. The legs of a right triangle have lengths 3, 4. Now here we go. This is the kind of problem we did before. The legs, so this is 3 and this is 4. So it's a right triangle. So we know, because we know Pythagorean triple, 3, 4, 5, we don't have to do the Pythagorean theorem, which will save us tons of time, is 5. And they want to know what is the perimeter of the right triangle with each side twice the length of its corresponding side in triangle ABC. So we have to add 2, so it's going to be 6 plus 8 plus 10. We add those all together and we get 24. So there we go. Okay, another charty thing. The table above shows the number of car rental locations for 5 car rental companies. For which of the 5 companies is the ratio of the number of foreign locations to the number of United States locations the greatest? Now you have to figure out ratios. They want foreign locations first to the United States. So all you're going to do is start putting in your calculator 4,000 divided by 1,400. So that's your first ratio. So you're going to go and do all those ratios. Just write your answers down somewhere in a neat, orderly way. So this is going to be 2.86. And I'm just going to go through and list all the ratios. 2.54. That would be the second one. The third one's going to be 3.58. So that's biggest yet, right? Here we go. The next one is going to be 1.83. And the final ratio, so you're taking foreign, so you're going to take 2,100 divided by 762, and we're going to get 2,076. So the biggest one is going to be this one, which refers to C. You can also see it's the biggest. You would have to take 3 times this to get there, so you could kind of look at the numbers, but it's easier just to make it into the ratios. So ratio is the number divided by the other number. It gives you the ratio. Okay, 10 through 11. 3 more pages yet. Okay, so the xy coordinate of the plane above line N is perpendicular to line L. What is the slope of line N? Okay, you can figure out L, the slope of line L, pretty easily here. It's crossing right here, and it's crossing right here. So if I do the slope, I go down 1 to the right 1. So it's going to be, the slope of L is going to be -1/3. It's really easy to see that one because it crosses the x and y axis. Now they want us to know the slope of line N. Well, if it's perpendicular, you know the slope is going to be the negative reciprocal. So the slope of N is going to be 3. You can almost just figure out the slope of N because we have this point, and then this point doesn't seem to end up in the right place here. Let's see. So if we do rise, here we go, yeah. If we follow this up, it's just a little bit harder to see. So you can see N without knowing anything about the perpendicular. You just go up 1, up 3, over 1. It's just a little bit harder to see because we don't have any straight lines here. All right, just keep in mind if it's perpendicular, it's the negative reciprocal. of the line it's perpendicular to. K is a constant, and 2x plus 5 equals 3kx, and it's for all values of x. Now this is just like the one that we did, only it was more difficult in the other one. You can pick values of x, and then we only have one variable left because it says it's true for all values of x. Now when I first did this, I let x equal 0, but I ran into trouble. I just got 5 equals 5, and that didn't help me at all. So I didn't get discouraged. I said, okay, now I'm just going to let x equal 1. Because it's true for all values of x, I can pick any value of x. So here we go. 2 times 1 plus 5 equals 3k plus 5. So I'm going to get 7 equals 3k plus 5. Subtract 5 from both sides, so you get 2 equals 3k. And guess what? K equals, if I divide both sides by 3, 2/3. And that is an answer. So just knowing, I mean, this is a pretty good trick for all values of x. You can just pick a number. It makes these problems very bearable. Okay, are there more on this page? Is there another one hiding? Nope. Okay, next to the last page. Okay, the sum of 11 integers is 0. What is the least number of integers that must be positive? All right, this one is just downright mean that they give us this problem. So 11 integers have to equal 0. So you could have integers such as, we need 11 integers. So if I started with -1 plus -2 plus -3, and I went the whole way up here till -10. So that's 10 negative integers, okay? Because they want to know the least number of integers that must be positive. So I'm doing 10 negative integers. If I added those all up in my calculator, I would get -55. Oops, I just lost my pen. Hold on, there we go. So, waiting for my pen to return. There it is. So if I added all these 10 negative numbers, so these are 10 negative numbers, and I listed them there. 10 negative numbers. If I add those up in my calculator, I get -55. Well, I could have any 10 negative integers, and if I just had one positive integer, what is the least number of these integers that must be positive to get 0? I just need one positive, and I would get 0. So it doesn't matter what 10 negative integers, add your 10 negative integers up and then pick the positive integers that's opposite of the total of the negative integers, and you're at 0. So you just need one positive integer. Yikes, that was tricky. Okay, maybe there's something more fun coming up. All right, certain game, each token has one of 3 possible values. You can have a 1-point token, a 5-point token, a 10-point token. How many different combinations of these tokens are worth 17 points? Well, try to be systematic when you come with these. There's no shortcuts to these guys that I know of. So I just figured out, okay, so there's 10-point tokens. So if I have a 10-point token and a 5-point token, how many 1-point tokens would I need? Sorry, I would need 2 1-point tokens. All right. Can I start with 10 anymore? Yes, I have one more possibility of starting with 10. I could have a 10-point token, and then I could have 7 1-point tokens. 1, 2, 3, 4, 5, 6, 7. So far we have 1 way, 2 ways. Okay, there's no other ways to start with 10, so I'm going to start with 5. So I could have a 5 and a 5 and a 5, and then 2 1s. All right, let's move with, let's just do 2 5s now. A 5 and a 5 and 7 1s. And then I can get rid of another 5. I could have a 5 and then 12. Whoops, I did that wrong. And then I could have 12. And then the 6th way is I could just get rid of that 5. I could just have 5, 5, 5, and then 2. So there's 6 different ways to, different combinations of your tokens. The thing with these is try to keep yourself as organized as possible whenever you're doing these kind of pattern problems. Try not to just go all over the place with those. All right, the next one's a knowledge-based problem in a way. we have a graph. What is the following could be the graph of 2 times f of x? Well, you have to know if anytime you have like any sort of parabola or whatever, if I had y equals x squared, that's going to be a parabola. If I had something like y equals 2x squared, the value of, hold on one second, I have to let my dog out. Sorry about that. She wouldn't quit until I let her out. What that value does before the function is it's going to make the function stretch. It's going to give you a vertical stretch. If I had something like this, if I had something in my function like x minus 1 quantity squared, that means it's going to move to the left 1 unit. So if it's in the parentheses, it's going to move left. If it's added on to the end, like plus 4, it's going to move up that number. But this is the number that's before the function. So if there's a number before the function, it means it's going to vertically stretch 2. It's going to increase on the y-axis 2 units. So I'm going to look at my pictures here. This one went up. I don't know, it looks like it went up maybe 1 unit. Okay, that doesn't have anything to do with that going up. This one looks like it, what did it do? It came down. Okay, there's nothing subtracted off of it. This one looked like it shrunk, and that has nothing to do with it. And then you can see on the last one, oh, there's more of these. This one actually stretched. You see how it's stretched up? And so it's stretched up 2, so this is your answer. So the number before is your vertical stretch. Okay, vertical stretch is going to, the y coordinates are going to move up 2. I'm really close to being done. I just did another one. I just paused my speaker thing. Okay, put it back on. Okay. Okay, last page. As soon as I get there. All right, last page. All right, the first term of the sequence above is 2, and every term after it is -2 times the preceding term. How many of the first 50 terms of the sequence are less than 100? Okay, you can figure out all 50, but you don't have time to do that. So we have to think of shortcuts. So let's just start our pattern. So we have 2 times -2 is -4, times -2 is 8, times -2 is -16, times -2 is 32, times -2 is -64. Think about this problem. I think anyone could do this no matter where you're at in math. Times -2 is 128. Now you can see all the positive numbers from here on out are going to be greater than 100. So we're going to have no more positive values. So only half of the numbers are going to be negative. So we're going to have 50 terms. How many terms are going to be positive? How many terms are going to be negative? Well, there's going to be 25 positive terms altogether and 25 negative terms. Okay, let me try to explain this as best as I can. So we used 1, 2, 3 positive terms so far, so I'm going to subtract off 3 positive terms. There's only going to be there's only 3 positive terms, so let me just put this down here. So there's going to be 3 positive terms altogether. Negative terms, there's going to be all 25, right? Because all the negatives are going to keep getting smaller and smaller and smaller. So only 3 of the positive terms worked, and all 25 of the negative terms worked, so we have a total of 28 terms that are going to be less than 100. That one's just smart thinking. There's always a smart thinking way to do everything. There's rarely a time. That token problem, we had to list them all out, which didn't take that long. This one would take a little bit of time. You could do it, but just start thinking, okay, none of our positive ones are going to be less than 100 anymore. So we only used 1, 2, 3 positives, but we're using all 25 negatives. And we only have one more problem. Okay, I love doing this one because it's so crazy. A cube with a volume, I just would love to see your work on this because it would probably be quite entertaining. Some of you probably did this mathematically correct too. All right, so you have a cube. The vertex is 8, it has volume 8 cubic centimeters. It's inscribed in a sphere. So, so that each vertex of the cube touches the sphere. What's the length of the diameter in centimeters of the sphere? Well, if you have a sphere around this, it's going to be touching this point and it's going to be touching this point, right? It's going to be touching this point. It's going to be touching all the points. So you just have to, there's no way I'm going to draw a sphere around here. That would be not good. So you want to find, if it's going to touch all these places, you want to find the diagonal of the sphere. I am going to pick a different color for this. So you're going to find the diagonal of the sphere is going to be the same thing as the diagonal of the cube, right? Now here's the tricky part. Memorize this, okay? Because it could come in handy and it could save you minutes and minutes of work. So a diagonal of a cube, equals the side times the cube root of 3. So if the volume of the cube is 8 centimeters, it means that this is going to be 2, this is going to be 2, and the height is going to be 2. So a side is going to be 2. So a diagonal of a cube, please memorize this, is just going to be the side times the square root of 3. So there you go. You could have done all kinds of special triangles inside of here, and I've done it that way before, but once I learned this formula that the diagonal of a cube is 2 square root of 3, that's all I ever do. So you might not see that come up at all in this book. It might, but keep that in mind in case it comes up on the SAT. All right, so that's it for SAT Test 3 Section 8.